Alrighty, so today we're talking about section 6.2, which is all about the standard normal distribution. Right, and this one is really important. One, because if you want to use the tables, right, remember I said last section that we're going to have two options. We're going to have tables where we can just look it up on a sheet of paper, or we're going to have our calculator functions. If you want to use tables, you have to use the standard normal distribution. That's the only sort of option you have. If you want to use the calculator, putting it into standard normal distribution means you have to input slightly less, though you might have to do more work on the front end. So we're going to talk a little bit about standard normal distribution. And the standard normal distribution is always a z. It's not x anymore for standard normal. If you're talking about the standard normal, right, you call it z, and that means it's a normal distribution where mu is 0 and sigma is 1. Right, so it's a normal distribution that has 0 mu and 1 sigma. And we can turn anything else into the standard normal. So if x is some other normal distribution, right, it just has a mu and a sigma. And x is a value there, then z equals x minus mu divided by sigma, right? We called that the standard score before. So it's going to be a value in z, in that standard normal, and the probability that x is less than or equal to little x is the probability that z is less than or equal to little z, right? So the problem with the table in general is that there are an infinite number of these guys, of these x's, right? So there's no way to write all of them down on a sheet of paper. It's pretty easy to write exactly one on a sheet of paper, right? We've managed to do that pretty concisely. And it turns out that if we can figure things out about this standard score using our table, that gives us exactly the value we want for all those infinite different normal distributions, right? So as long as we take our x values and translate them into the standard score, we can look that up on our table. So there's some caveats about our table that we'll go over briefly. So the table is always probability that z is less than little z, right? At least most of the tables that I've ever seen, they could always do a greater than table, but I've always seen them as being less than. But symmetry says that the probability that z is greater than or equal to z is the same as the probability of z being less than or equal to negative z. Right? So that's a nice thing that symmetry gives us. Also, we know that that's going to be equal to 1 minus the probability that z is less than z. Using the same idea that we had last chapter, where it's the complement event, right? Z is either going to be greater than or equal to or strictly less than. It's nicer in this case because the probability that z is less than little z is exactly the same as the probability that z is less than or equal to little z. So we could look this up on the table, or we could look this up on the table, and that lets us get these greater than values. Right, so that's one option we have. And then the other type of problem we might want to answer is the probability that z is in between two values, right? Again, the table only wants less than or equal to values, but that's not too bad because this is the probability that z is less than little z2 minus the probability that z is less than little z1, right? And we can see that if we draw a graph, right? So here's 0, maybe this is z1, and this is z2. Let me get some colors in here. This is going to be all of this stuff, right? It's going to be this area. This is going to be just this stuff, right? And the thing that we actually want, this, is going to be just this stuff, right? So we can see if we take all of that red stuff, but then take away the part that's covered in blue, we get exactly the stuff that's colored in yellow there. Stop that. The idea of the area under the curve to get this double-sided probability here, right? So that's if we want to use the table, right? Because the table is always going to be talking about less than or equal to, so we have to put it in that form. If we're not dealing with the table, right? If we're dealing with, if we're using our calculator, the probability that z is less than or equal to little z is going to be normal CDF. And we have something a little bit weird here, and I'll show us how to plug it in a second. Right? And that's all we have to put, right? This is secretly standing in for negative infinity, and that says that we want to know everything from negative infinity up to z, right? And that's exactly what strictly less than or equal to z means, right? If we want to do it the other way around, then we do normal CDF. And this time we want to start at z, because that's as low as we want to go. And then we want to let it go all the way up to basically positive infinity, as best the calculator understands it. All right? Now, this one is what the calculator is really made for doing. All right, it's why we've got to put that weird infinity stuff in there. So this is going to be normal CDF Z1, Z2. Because Z1 is as small as we want to go, and Z2 is as big as we want to go. So to get that infinity idea in there, that is not the one I wanted to hit. To get that infinity one in there, we would do 1, right? Then we want this double E that shows up above the comma button. So we would hit second and the comma button to get that E, and then 99. So that's what I mean by that 1E99, is that it's this capital E that shows up as a double E on the button, and you get it by doing second and then the comma. Right? So, yeah. So there's not a whole lot I can do without my calculator working. Right? Maybe, let's say, we want to find the probability that x is less than 20 if x is a normal distribution with 30 mean and 10 standard deviation. So for now, because we haven't talked about how to do it any other way, even on our calculator, that'll be next section, then we're going to translate this into the standard normal, right? So we want to figure out what z is. If x is going to be 20, the mean is 30, and the standard deviation is 10, so that's -1, right? So that tells me that the probability that x is less than 20 is equal to the probability that z is less than or equal to -1. Right? Now, that's one I could perfectly find on my table. It's hard to explain without a picture to look like, and I don't have one of those on my tablet. But you always look for z on the outside. You look for the first couple digits on the left, usually, and the last couple digits on the top. And then you look for the center of the table to get the probability. Or we can plug this into our calculator. This is normal CDF. We don't have anything smaller than z, so we're going to put -infinity there. And bigger than z, we want to stop at -1. Right? So that would be how we would find that probability using our calculator and what we have now. Right? So let's find the probability that 0 is less than z is less than 1.76. Right? Now, again, one of the things we could do is we could look on our table for this probability and subtract this probability, right? Which I can do this one in my head. This is 0.5. So really, we only need to look up one of these, right? Because the mean is always going to divide your... it's always going to divide your probability in half, right? Or we could plug the original thing into the calculator and say normal CDF. We've got something on the left, so we put the 0 there. We got something on the right, and then the calculator gives us an answer, right? So those are two options we have there. And next time we'll get a sort of simpler way to do problems like that first one, because it turns out our calculator is doesn't actually care about having to do standards. It's not restricting itself to looking up on a table, so it can talk about any normal distribution. So I'll see y'all for that one.